the last session we have studied that what is degree measure, what is radian measure, how we can convert from degree measure to radian measure. Okay. Also, in that we have studied what are all the common angles. Okay, those common angles were what? 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. The same in the radian measure: 0, pi by 6, pi by 4, pi by 3, pi by 2. You remember? Now one by one we are about to calculate. See the ratio of sine, which means sine 0 degree. The sine 0 degree, simple. When you will get 0 degree? See, this is the angle measurement I said, theta. Okay. In this, if you draw one line, we can make this right angle triangle, and this side is opposite side, this is adjacent side, this guy over here is hypotenuse. Okay. Now sine 0 degree if I am taking, our theta value is 0 degree. When that will be 0 degree? If there is no rotation. This opposite side, this ray is the ray, that ray will coincide with this ray. So which means opposite side will what? Reduce, and that goes to where? What is the length of opposite side in this? Opposite side 0 divided by adjacent side. We don't care what it is. So the value is 0. So sine 0 value is 0. Likewise, sine 30 degree we have to calculate. To calculate sine 30 degree, you take this equilateral triangle. In equilateral triangle, all the angles are 60 degree, you know, right? We draw one angle bisector for this angle, which is perpendicular to the base. Why? Because in right angle triangle only we will apply Pythagoras theorem. Pythagoras theorem. Yes, Pythagoras theorem will apply. We will apply the trigonometric ratios in right angle triangle. Now the 60 degree split it into two equal halves. Then this will become 30 degree. Let A be the length of this side, and this will split the base. So this half is A by 2, this half is A by 2, and here all the sides are equal, right, in an equilateral triangle. So let all the sides be A. Now sine 30 degree we need to calculate. You take this right angle triangle. Can you see this right angle triangle? So in this sine 30 degree means our theta is what? 30 degree. Okay. What is sine ratio? Opposite by hypotenuse. The opposite side for 30 degree is what? Opposite side of 30 degree. A by 2. So opposite side is A by 2. What is its adjacent side then? Hypotenuse, man. Hypotenuse is always, oh sorry, my bad. Hypotenuse is what? A. That is all. If you simplify these two, what you will get? Sine 30 degree is 1 by 2. In this triangle itself, we can find the value of 60 degree as well. How? The height of the equilateral triangle is root 3a by 2 by using Pythagoras theorem. If you use Pythagoras theorem, these two sides are known, this is unknown. You can equate this. Now in this, sine 60 degree, man. What is the length of opposite side of 60 degree? Root 3 a by 2 divided by hypotenuse a. This two will get cancelled. Is sine 60 degree. Okay. Next, this 45 degree. Take one right angle triangle. Isosceles right angle triangle, like we'll take. Why isosceles right angle triangle? This is 90 degree. Since this is isosceles, we have here 45 degree, here 45 degree. Okay. So isosceles means this side also A, this side also A. Then this side, by using Pythagoras theorem, we can find root 2a. Why it is so? Why is it so? The hypotenuse is equal to square root of side square. A square plus a square, you will have 2 root 2a square, and this a will come out. Root will stuck in that root itself. 2 will stuck in that root itself. That is the value of this hypotenuse. Now sine 45 degree. What is the opposite side of sine 45? A by hypotenuse root 2. These two will get simplified. Sine 45 is 1 by root 2. Sine 90 degree we want. Shall we take this triangle itself? No. Not possible. Come back here. This leg will take. Here 90 degree. Better we'll take the previous itself. Previously what we have done, just like one triangle we took. The same diagram I am drawing here, man. Okay. This is our angle theta. And this is hypotenuse. This is opposite side. This is adjacent side. Okay. Now, you see, this theta, when it will become 90 degree? If this line moves and moves and moves and moves and collide with this opposite side, is it or not? This line is like moving, it collide with this opposite side, is it or not? So then that diagram would be nicely explained. See, here theta, when this will become 90 degree, when the theta increases, it goes on and it collides with the opposite side, which means we have the case hypotenuse will be equal to opposite side if 90 degree happens. Then what is sine 90 degree then? Opposite side by hypotenuse, right? We have this, both are equal. So both will get cancelled. 1. Using the same triangle, same thing, we can calculate for cos as well. Now come back here. Instead of sine 0, we will calculate cos 0. How do you calculate cos 0? You see, when this will become 0, our hypotenuse will be equal to adjacent side. This hypotenuse will be collides with the adjacent side or not. Then we have adjacent side equals hypotenuse. Then cos 0 is what, man? Cos 0 is adjacent by hypotenuse. So our cos 0 is 0. Now cos 30 degree, which triangle we should take? Yes, man, cos 0 1. What I written? 0. Sorry, my bad. Cos 0 is 1. And then for 30 degree, which triangle we should look for? This isosceles triangle. What triangle? Equilateral triangle. Clever boy. See, this equilateral triangle, 30 degree same. But instead of taking for sine, we should take cos here. Cos means what ratio? Cos 30 degree. What is adjacent side of cos 30? Root 3 by 2. A by 2 by A. Then root 3 by 2. Same like cos 45. Which triangle we should look for? Isosceles right angled triangle. Isosceles. In this cos 45 degree, what value you can find? One by root. Perfect. Good. Then 60 degree. Which triangle we should look for? The equilateral triangle. In this 60 degree, cos ratio. 1 by 2. Clever. Good. Then 90 degree. 90 degree, this case we discussed. This moves on. This two will collide. Okay. So this adjacent side will become what? Opposite equal to, okay, adjacent. What will happen to adjacent? What will happen to this adjacent side, man? This shrinked here means this side is shrinking. Moving further. 0. And adjacent side is 0. What is cos ratio? 0. That is it. The same triangle, we can find tan as well, cot as well, sec as well, cosec as well, everything you can find. Okay. Any doubts in this? This is how we should calculate for this common angle. But there is a shortcut for this. Instead of memorizing this table, instead of working out like this every time, we have a shortcut. You want the shortcut, or is this okay for this? Yes, that you know or not? Okay, that will help you, man. Whatever it is, the hand trick. We are going to learn that hand trick. Yes, sure. No. They don't think like. Okay. So that is our next section. I'll give you the shortcuts. Using that, we are going to reframe this table, but you should know how this table came. For 30 degree, 60 degree, we should take an equilateral triangle, and the height of the equilateral triangle is root 3a by 2. Okay. And for 45 degree, we should take isosceles right angle triangle. 0 and 90 degree, it collides with either side. Either it collides with opposite or adjacent based on 0 degree or 90 degree. That is it. That is the idea. Okay. Now we'll go to that hand trick. Have you copied writing everything?